Hello everyone, and welcome to week 3 of cartographic design. The topic for this week is mappable data. Up until this point, a lot of the data that we have been used has been given to us or predefined, so we really haven't thought about where some of the data comes from and how it gets into a GIS format. So this week we're going to talk about what are some forms of mappable data, and just what at a glance may not appear to be mappable data in a lot of ways is data. It's just up to your imagination and your GIS skills to get that data in a format that's usable in GIS. So hopefully by this time you went through the self-assessment and you were able to come up with the answers to the scenarios that were given. I'll provide feedback on those scenarios individually. So in terms of what is considered mappable data, I think let's start down here at the third bullet. We're all used to working with shapefiles because we've done so. For some of you, this is your second class. For some of you, this is your third class, depending on when you started. You are really well aware of what a shapefile is, and most of you know what a geodatabase is and a coverage. Essentially, that they're just different data models is all they are, just different ways of modeling GIS data, and that data model has developed over time. Just as software kind of developed with different versions, so does the data model for GIS. So the first data model for GIS was the coverage that then transitioned into the shapefile, and now the most current data model are geodatabases. And when you add this data to ArcMap, you really don't see a difference in terms of what it is, because the polygons are all the same. You know, that doesn't change. It's just the way that it's represented in a geographic format. So this is kind of like the easy one, because this is data that already exists, and we have to just click on our Add Data button and it populates our map. Now, other data that's mappable that might not necessarily seem to be mappable are just spreadsheets of data. Let's, for example, say that I have a spreadsheet that shows all the counties in Pennsylvania. It lists all 67 counties, and the second field has the number of preserved farms for each of the counties. And this is, again, just spreadsheet data. While this isn't immediately GIS data, it can be made very easily into GIS data by doing the process of a data join, which essentially appends a data table to a shapefile. So as long as you have a shapefile of your Pennsylvania counties, you can append that spreadsheet data to it. So that's actually a really quick and popular way of adding attributes and values to your data. So a lot of data that we get is in the form of spreadsheets that can be transitioned over to shapefile geodatabase format. Another type of data that is considered mappable is a spreadsheet or database of addresses. In the Intro to GIS class, you learn how to geocode, which is essentially getting an address location onto a map by the software assigning its geographic latitude, longitude coordinates. So that's a form of mappable data. Another form of mappable data that you worked with in the intro class, and for those of you that were in the remote sensing class last semester also did this, if you have the XY coordinates, again in a spreadsheet or database, as long as you have those coordinates, you can actually get those on a map. For instance, let's say that you're an avid hunter and you go deer hunting every year, and as you're out deer hunting, you take a GPS with you that gives you the latitude and longitude coordinates of your best hunting spots. You can then get that data onto a map just because of the fact that you have the latitude and longitude. And if you remember, you do that by right-clicking on the data table and go to Display XY, and then it allows you to display that latitude longitude data. Now, something to just keep in mind with the Display XY function, we've used latitude longitude pretty much exclusively for that function, just because that's usually the way that coordinates are given. But also keep in mind that there are state plane coordinates in northings and eastings, and UTM coordinates are also in northing and eastings. So it may not always be latitude, longitude that you're showing, but as long as you identify with the proper coordinate system that you're using, you will be able to get those coordinates onto a map. And just as a quick reminder, when you're doing, if you're showing latitude, longitude coordinates, the coordinate system that always goes along with that is WGS 1984. So essentially anything that has some type of geography or location associated with it can be put into a GIS format. This conversation this week is particularly important because you are going to start working on your final project. Essentially, your topic proposals are due next week. And one of the things that you're going to have to think about is how to get what you're trying to show into mappable data. For some of you, you might just have an idea of what you want to do. Like maybe you want to show where all the historic York County distilleries were located. Well, how are you going to get that on a map? What are the best mechanisms? Or maybe you're going to be looking at number of tornadoes by Pennsylvania County. Again, that's not something you're just going to be able to download into a GIS format. Essentially, you're probably going to have two things with that. You're going to have to download the county GIS file, shapefile, or geodata or feature class, and you're going to have to get a spreadsheet or something that indicates how many tornadoes there are in each county. Then you can do one of a couple things. If you do have it in a spreadsheet format, you can just do a join, like we've done in an intro before, or you could just actually manually add that to the attribute table by adding a field and then manually entering those values. And it's highly dependent on the format in which you find that data on how you're going to do it. Sometimes the only way of doing it is by just adding a new field to the attribute table and manually adding them, so it's not as automated as some of the other procedures, but it's an option for getting things done. So where do you find data? And this is essentially, there's no one answer for it, and there's no one answer because there's so many different types of data that you might need, and you just kind of have to start learn how to do research to find the data that you need. Probably one of the best things that I've learned over the years is if you can identify what agency might be responsible for creating that data, and not every single thing that you can think of, there's an entity responsible for creating it, because let's say your topic is number of Bigfoot sightings per U.S. county, probably nobody has aggregated that data in a GIS format. And there's no one entity responsible for that. That's something that you would have to put together. But there are some data sets that are that different agencies essentially are in charge of. For instance, just looking over here under the federal agency topic, the Fish and Wildlife Service, one of the data layers that they're responsible for is the National Wetlands Inventory data, which essentially tells if it gives you the classification for what type of wetland every single part of the United States is in, so whether or not it's even in a wetland. And then the U.S. Census, as we know, every 10 years, the census is conducted, where we get a picture of the overall population of the United States. And essentially, what the U.S. Census generates are data files, like basically you would download it in an Excel file or a CSV file, comma separated values. You would just get the table, and then you would do a join based on the geography. So they're responsible for that. The Park Service is responsible for their land. So if you needed like a national park boundary, hint for the assignment, you could potentially go to the Park Service website and download it. The thing to keep in mind is that your experience that you have at each of these websites in terms of how they share their GIS data is completely different. So there's no one way of doing anything when you're finding GIS data. Just as like if you're writing a paper for a particular class, there's no one source for everything that you're ever going to need. You have to actually research it and find out who has what. It's a very similar procedure in GIS. But one of the things that you'd be really well served in doing is trying to get a sense of what each agency creates. And if you go to POSDA, if you go to the FTP site there, you're going to notice that a lot of things are separated by state agency. That means that that state agency is responsible for that particular data layer. For instance, DCNR, the Department of Conservation and Natural Resources, they have like things like trails, and like CCC camps, all sorts of stuff. And TopoGeo, or the Geological Survey, is a bureau under DCNR, and they're the ones that have like the bedrock geology, the physiographic provinces, and I think you all are pretty familiar with that data because we worked with it in the intro class pretty extensively. So again, if you need those kinds of data sets, you would know exactly where to go. DEP has certain data that it's responsible for, as does the Department of Agriculture. So get to know what they all do, and that can be really help you down the line when you start looking for data. You know exactly who to go to. So there's lots of ways or lots of places to find data, and it's not always up on a website. So like for instance, the Nature Conservancy, they have bucket loads of data. They're not going to post it online, but if you ask for it, they would likely happily give it to you. So don't be afraid to pick up the phone to ask for data, because that goes quite a long way. So many places to find it. Now, in terms of some issues with the data, there's 8 basic issues with mappable data, and I'm going to go over each one of these. The first one is the fact that maps will depict either phenomena or data. A data example would be population, and that's probably one that I beat to death in the intro class, because we always do examples showing population, and that's essentially just showing that particular data and representing it on a map. Phenomena is like a temperature map, and because of the nature of the data, they are going to look very different. So in terms of temperature data, and we're going to actually be doing an assignment on this in a couple of weeks. Data like temperature, something that gradually changes over space and time, is not as easy to depict as something that has an exact boundary to it. And let's just pretend this is temperature data, that all of these different dots are a different temperature. And that's a really hard map to interpret. But if we do a process called interpolation, where it connects values of like temperature, we get something that looks like this. We essentially get a surface map that shows us the gradation in temperature. And you'll be doing this in about 2 weeks, where you'll be learning how to generate this kind of data and then also create contours from this. You'll be actually making a temperature map of Pennsylvania, so that you learn how to do a process called interpolation. So you have to keep in mind that there's different types of data that can be represented. Another thing is that, and I bring this up because this is something that can be slightly problematic, and that's looking at raw totals versus weights and or densities. So looking at this map, let's go to Pennsylvania map. So here's a map of Pennsylvania counties, and as you can see, not every county is the exact same size. So then how do you compare counties with different sizes in terms of population? It's very difficult to do that, because it's not really fair to compare Central County, that is quite big, with this small Philadelphia a county, because you're essentially comparing apples to oranges. So wall total doesn't really mean much, because you would think that something that's much larger will have more people in it, and some other smaller areas won't. So density is a little bit more appropriate. And I'm actually going to show you how you can do this. Let's go to this example. So in this attribute table, I have data that shows the population for every 10 years up until 2000. So if I just make a quick graduated color map, as quick as the software will allow me to make it, you can see how population is distributed over the state of Pennsylvania. And again, this is just showing wall totals. This is not showing, by square mile, which is probably a better indication of this. So if you wanted to normalize your data, there's a couple of different things you can do. If you go back here, you can see this normalization value under here. And there's some things that are built into ArcGIS that allow you to normalize. The first is like the percent of total. So it'll tell you what percent of the total population each county has. So let's just kind of take a look and just see how this map changes. So if I hit apply, you can see that. And actually, let's just go back to the other so we can compare it again. It doesn't really change all that much. But let's say that we wanted to do it by square miles. So what we would need to do is, in this area here, have a square miles field. If we don't have a square miles field, we can add one to our attribute table. And by the way, a quick way to open up your attribute table without having to right click and go into open attribute table is just hold down your control key and double click your data layer, and it opens up the attribute table. I'm going to add a field called square miles. And I'm going to select float or double for this. Essentially, the difference in these data types are a short integer is any value between negative 32,000 and positive 32,000. Anything that's a long integer is outside of that range. A float means that you can have 7 decimal places after the decimal point, and double is 14. So if you think, unless you know it's going to be a whole number, and things that are going to be whole numbers are things like population, things that you can actually count. But when like square miles, there's no way that that's going to be a whole number when you calculate that. So you're going to want to select something that has decimal places, so float or double. I'm going to hit OK, and then I'm going to go over here and calculate this field. And for those of you that remember how to do this, you just right click on the field, go to calculate geometry, and select area, select square miles, hit OK, and it will generate that outcome. And then if you go over here, and then you can normalize this by square miles, it just gives you a better indication of where the most densely populated areas are. And you can kind of see that it is eastern Pennsylvania, and that makes a lot of sense, as well as the Pittsburgh area. So that's a data normalization. So again, just keep in mind the story that you're telling when you decide whether or not wall totals is appropriate or densities are appropriate. What I have a habit of doing, and I've done this a lot with the hack maps that I make, every semester I make a map showing how many students there are by zip code and by school district. I do both a wall total map and a percent of total map, just so that you can see it a couple different ways. And there's actually a third way I show it. I forget the way that I guess it is square miles, because everybody wants to see in different ways. I try to accommodate every single audience with it. I essentially make one 11 by 17 map that has all 3 maps on, and then they can see the wall totals, they can see the densities, they can see the percent of total. So it just helps them build the picture of how students are distributed throughout our service area. Back to the lecture. So another thing to be mindful of as you are designing maps is providing context and reference for your maps. Let's say, for instance, I'm mapping bars in the city of Harrisburg. There needs to be some geographic reference provided, so it's not just a bunch of dots on a really basic and open map. Like I can't just have like Harrisburg city boundary and the dots, because that doesn't give anybody any real geographic context to it. So add things like highways, major roads, other features that give you that context, so that people can understand its the geographic situation of the data. Now, something about context and reference layers. They should be something that are subtle in the background, because you want your main data to stand out and pop off the map, while the reference layers are kind of hidden behind things. And a good way of doing this is, for instance, let's just say that I'm making that map of bars in downtown Harrisburg. I would have a roads layer on there, but I might set that a little bit transparent to kind of make it a little bit more subtle. So that's one thing you can do. You can use a base map that is not as in your face as some of the others. Like if you add the imagery and the imagery with labels, that gets just busy really quickly. That's where like the light gray canvas and the dark gray canvas can come into play. Is when you want your data to really pop off of the map. And I'm a big fan of those canvases, because it really does help make your data the center of attention. So they should be subtle and in the background, but enough to provide the map user with some information about its geographic situation. Now, in terms of getting data, we already talked about a couple of ways of doing this. In your week 1 assignment, you did a base map assignment where you had to digitize various features. So essentially what digitizing is tracing over top of like aerial photos or some other data that allows you to create geographic data. So for instance, you might do this if, like, I'm making a map of the Hack Midtown campus, and I need a point for where the parking lots are. I might just quickly digitize them as a point, or even a polygon, depending on how I'm making my map. So just drawing features on screen is one way of creating data. And I imagine some of you, for your final project, will be doing this quite a bit, is just because you'll be having to create that. For those of you that were in the remote sensing class last semester, if you remember when we were doing the Marcellus project that you loved so much, you had to digitize where all the well pads were and where all the pipelines and gas roads were. So this is an example of when you would digitize. Census data. If you want anything having to do with demographic data, knowing about the population, income, poverty level, unemployment, just sheer population, the census, you can go to American Fact Finder and download it on different geographies. And in a later lecture, I will actually be doing a demo of this, because it's not the easiest topic to master, because you first have to master census geography, and then you have to master the very cranky American Fact Finder application that the census has built to get that data, but we will go through that. But you can get bucket loads of data from the census. Geocoding. If you're going, for your final project, if you're going to be doing anything that has an address associated with it, you can compile a spreadsheet of addresses and geocode them. GPS, and I think there's already one of you that may be using GPS to get your data points. Let's say that you want to map where all the prehistoric caves are in Pennsylvania. Not that I know that's actually a thing, but like, let's say that you want to map all of those. If you have a GPS unit, you can collect that data, and then you can export it out as a shapefile format. And then imagery. Imagery is always something that can be used for different projects. So In terms of data, you all know that there's qualitative and quantitative data. Qualitative data is anything that has like a category attached to it, or is essentially a text field, is the basic way that I explain this. Quantitative data is anything that's a number, for the most part. I would argue that a zip code is not really quantitative data, it's qualitative data, because I would never put it as a data type as an integer. I would actually use that as a text data type, but that's a whole nother story. So you have qualitative and quantitative data. With qualitative data, you've learned that in ArcGIS, unique value is the type of map that is associated with qualitative data, and it just shows the difference in kind or type. So let's say that we were mapping parcels in Bethel Township and we wanted to know which ones were residential, which ones were farmland, and so forth. That's a unique value map looking at qualitative data. Quantitative data is looking at numbers, and these numbers can be in different formats. They can be just raw totals. They could be interval, ratio, and ordinal. So to kind of show you an example, this is actually showing both quantitative and qualitative data. Up here, this is showing like the unique value type of thing, while down here this is showing you quantitative data. So you can see the difference. In terms of ordinal data, this is kind of interesting, and this is what to keep in mind in terms of even the two examples that they have here are very good ones. If you're making a map that's showing roads, you're going to want your highways to be obviously a larger line thickness than just a secondary road. Same as with cities versus towns versus village, the symbology for them that should denote its importance. So that's intuitive to the map user of its relative importance in the grand scheme of things. We already kind of talked about how to transform data into average densities, total numbers, and rates. And that's essentially by using that feature in ArcGIS that I showed you, where you select the field and then you select what to normalize it by. And with that function there, you can essentially transform your data as shown here in any one of these different ways. So I encourage you to play around with that. And the thing about that, though, is you have to get your data in the right format for that to work. Just like I added to that population or that county file, I added a square miles field. I wouldn't have been able to normalize it if it wasn't there. So sometimes you have to do some field additions in order to make this work the way that you want. And now something that I want you to keep in mind, especially for this Yellowstone assignment coming up, is data accuracy. Are your facts accurate? So make sure that you're double checking things and making sure that your data is accurately representing what the story actually is. Look at does the detail vary across your data? Is your data coming from a trustworthy source? And like the boundary, for instance, the park boundary for Yellowstone. The Park Service is probably the most trustworthy source on that data, so that would probably be the best place to go. If like you go to somebody's blog and download it, that might not be the best source, unless of course they have metadata with it that might explain how it was created. Are things where they should be? One of the things I'm asking you to do for the Yellowstone thing is kind of map how the hot spot has moved over time. Are they where they need to be? So just be careful of that. And one of the things that I would suggest, and I'll give you a little hint, that data in a GIS format is going to might be difficult to find. It might not be, depending on your data slowness. If you can't find it in a GIS format, remember what we learned last week about georeferencing. So let's say you find just an image that's not georeferenced. You can georeference that image and then digitize your hotspots from that. So hopefully that gives you a little bit of a hint of how to proceed on that one. You have to think about when the data was collected. Is it accurate at this point in time? For instance, let's say I'm working on blight in Camp Curtin right now, and I want to look at who owns each of the properties or each of the parcels in Camp Curtin, but my data set's from 2005. that's probably not the best one to use, especially when you can get an updated one relatively easily. So just keep in mind when the data was collected and how, if it's still relevant today. And then, are the data appropriate for the map goal? One of the things that I remember I had an issue with when I first started GIS, and I think a lot of us have the same issue, is that we find data that's kind of associated with the project, really cool data, we want to use it, but it just doesn't fit. And try to make sure that you are self-editing yourself in terms of what you put on there. With maps, simple is better. Don't overcrowd it with different data that might be confusing. Another thing to think about when you're trying to get your hands on data is the metadata. If there's no metadata with a file that you are using, I would be highly suspicious of that data unless you know the person or source personally that put that together. Metadata is the documentation about your data. It tells you why it was created, when, for what purpose, gives you the spatial reference information, it gives you what the attributes mean. Lots of good stuff is in that metadata. Any good, trustworthy data that's shared on the internet should have metadata. If it doesn't, be cautious and proceed very cautiously. Copyright, some data has copyright to it, so make sure that you're not violating that. The other thing is, and I don't have it up here, is dealing with data that's sensitive data. For instance, back in the spring, I was working on a project about habitat connectivity. And one of the parts of the project was to look at what endangered species were in each of the areas that we were looking at. That's not data that's shared publicly. That was something that was shared with me as a contractor, but you had to sign and say you want to do this and this with it. That's the same is true for archaeological sites and for the Historical Atlas project. Some of you, and I know one or two of you have mentioned this already to me, is that some of the data that you want is not available because it's archaeological sites. They don't put the exact latitude, longitude for that, so that's going to be data that is going to be difficult to get. It's not to say that certain people can't get that. For instance, let's say PennDOT is putting a road through a certain place. Who's ever working on that project is going to get access to, so that they know there are archaeological sites at that particular location. So just keep these three things in mind. Now, you're going to be working on your Yellowstone map in the next week. And we're at the point where I'm going to be pulling away from giving you data and having you find it and aggregate it into a format that's meaningful for the project. Keep in mind the map design process the whole time you're doing this. The first thing is consider what the real distribution of the phenomena might look like. And sometimes this is worth kind of just sketching out on a piece of paper what you think, how everything that you're going to be showing on the map is going to be pulled together. Number two, and probably the most important part of the whole process, is determine the purpose of the map and its audience. Speak to your audience. This map is meant for a group of geology students, so you know that they might know a little bit more about the geology, maybe not much more, but a little more, and also know that they're students. So, make sure you're defining things and explaining things in it. But never lose sight for who your audience is, because that would actually help in terms of the map design of how you want to put it together and how you want to speak to your audience via the medium that you're using. The third step is to collect data that's appropriate for the map's purpose. And again, that's kind of where this lecture comes into play, is that you have to figure out what data is necessary for your project to be a success. Once you get that data, which is, by the way, is the most time-consuming part of any project, is data acquisition and manipulation. Once you get that data and manipulate it into a format that's usable for you, that's when you really get into the designing and constructing your map. Make sure as you're designing and constructing your map that you kind of adhere to the rules of visual hierarchy. Essentially, the most important information on the map should pop first, and the secondary stuff should be in the background. And there's going to be a few different things going on here. You have to kind of decide what the most important parts of the map are so that they stick out and tell the story. And then you design and construct the map. The last thing is feedback. Feedback is probably the best way of assessing whether or not your map is successful. And there's different ways you can get feedback. We're going to be doing it in a little bit more of a formal process in the class where you're actually going to be posting your map to the discussion board. We're going to everybody's going to comment on it. I'm going to have certain questions that you're going to have to answer, and that's a way of getting feedback, is just showing it to somebody and letting them look at it and answer a series of questions to see how effective that it is. Another way of informal feedback that I like using is, let's say you hand out a map to everybody. You're at a meeting, you hand out a map to everybody showing whatever it is, let's say zoning, and everybody looks confused as hell. And they're really trying to discern what your map is showing. That's a form of feedback. Looking at people's faces and seeing, are they able to understand what's there? Do they look confused? Are there a lot of questions? Usually the quieter they are, it means that the map is more effective, or maybe it's just that bad that they don't know what to say. But a lot of times, if you just looking at people's nonverbal gestures can tell you a lot, and start getting able to read those because it does really help in terms of your map design. But we're going to be doing it through a formal process so that you are able to get some feedback on the maps that you're designing. So I'm going to show you a bunch of things right now that are going to tie into your projects this week and in the weeks to come. Just some tips and tricks having to do with data and data types that hopefully will help alleviate any issues that you might have. And as you can see, my light is on a timer and it went off, so excuse me 1 second while I go activate it again. And the back. Okay, so let's go to ArcGIS, and let's start with this one because this one's kind of fun. So what we're looking at here is a map of Pennsylvania Senate districts. If we open up our attribute table for this, we're going to see that we have a couple of different data fields in here. We can see that we have what legislative district it is. We have the last name of the current senator from that district, as well as the first name. And by the way, this format drives me insane. It's the stupidest way of putting it in, but that's just my little editorial. You have what their home county is, what their party is, and then you have a link here to their web page and so forth. So there's two different things I'm going to show you here. The first thing is how to combine these two fields into one field. So let's just say that you want it to have first and last name in one field, because that's how you want to label your map. So what we can do is add a new field. And we're going to call this rep_name. And remember, your field names have to be less than 13 characters with no spaces. Then we have to select the data type. Obviously, this is going to be something that's not a number. So essentially, the first four are non-choices already. And obviously, because it's just going to be somebody's name, it's going to be text. And then you can change how many characters you want it to be able to accept. And just don't randomly accept a default, because that can be sometimes bad. Sometimes it's not enough, and sometimes it's way too much. For example, if this was just like a yes-no field, 50 characters is way too much. We could get away with 5 characters. So just be mindful of that, because as you're starting to build data, those things take up disk space, and you just want to be cognizant of how large your files are getting. So I'm going to hit OK on this, and notice that this adds for me a new field. And now I want to populate it with both of these together. Now I could do this the long and hard way, and the way that would make me go a little bonkers, and that's by getting into edit mode and then just start manually typing those in, but I'm not that ambitious to do that. I'm going to use the field calculator to do that. So the way that we use that is we come over here and we right click on the field and go to field calculator. You're going to get a message that says you're going to do this outside of an edit session. Don't let that scare you, just hit yes. And then your calculator comes up. And I think we're all used to using calculators with numbers to do add, subtraction, all that good stuff. But you can also use it for text fields as well. So right here, this is telling me rep name is equal to what. So I'm going to build the expression of what the rep name is equal to. So I'm going to do last name plus first name, and then hit OK. And then it's going to calculate the records. And notice that it put both the first and last name in there together. So that's how you can combine fields if you need to do that. And what I would do after I would do this, you can determine whether or not you need those two old fields. If you don't need them, I delete them. If you think you're going to need them for whatever reason, you don't have to do that. Now, going back to this, we have a first name and last name. Notice in this field here, it has a comma behind the name. Now, if you go to label your districts, let's say that you made a map of showing the districts and you were asked to label it by the rep's last name, it would actually show that comma there and it would look ridiculous. And if it was me looking at the map and you made that map for me, I would say go back and get rid of that comma. It's just not appropriate. The way that you can do that is by doing a find and replace. And I'm first going to get into edit mode. And then do a find and replace. You want to find, and making sure your field is highlighted, you want to find a comma, and you want to replace it with nothing. So I'm just going to hit the space bar. And then hit replace all. Notice how that comma goes away, and then you can just go to editor, stop editing, and save edits. Now, again, you could have gotten into edit mode and went into each one of those and manually put your cursor in and hit the backspace and go down all 50 of them. But what I just showed you with the refine and replace is just a much quicker way of doing that. So that's a little tip with the field calculator and the find and replace functions. Now, this one, this is a map of the United States. And if we open up the attribute table for this, we see that we have a state name and some population statistics. Let's say that it's the 2016 election time, and we wanted to make a map showing the election results for the 2016. So what I'm going to do is add a new field. I'm just going to call it 2016 winner. And again, that's going to be text. I'm going to shorten that to 25 because the candidate's last name is not going to be any longer than that. Hit OK. Oops. Yes. See, and I went beyond my character limit. So let's say, and let's hope that this doesn't happen. Let's say Donald Trump took all but like 5 states. The only states he didn't take were New Hampshire, California, Kentucky, Oklahoma, and South Dakota. Let's say his opponent, and let's pick Bernie Sanders. I can't go with Hillary. Let's say Bernie Sanders took these 5 states. What we could do is get into edit mode and then do a field calculator of winner. Oops, sorry. The winner would be Sanders, so just type in the last name and hit OK. And I believe I forgot my quotes. I think that was the issue there. Sorry about that. Let's do that again. And yeah, you have to have quotes around it. Sorry about that. But notice how I populated all 5 of them just like that. Instead of me having to go down individually through each state to do it, you can populate them all at once. And then if I go and switch my selection to select all the other states that trump one, I could go in here and go to field calculator and now just change that to Trump. And I'm hoping that neither of these are the actual representatives for either party, but hit OK. And now we have that data populated. So it's just a much faster way of getting data into your table rather than having to go one by one. You can do mass if you just select out which ones you want to be what. So with that, I'm actually going to get out of edit mode. I'm not going to save my edits, and I'm going to actually delete this field so it doesn't mess up my data for later. And close that. And the next one that I want to go to is another field calculator example. And this is looking at Dauphin County block groups. And if I open up this attribute table, notice that I have in here a whole bunch of statistics about the different block groups. And the ones that I'm particularly interested in are these age cohorts. Let's say that we want to know how many people are 29 and under in each of the census blocks. Right now that's broken down into 4 different categories, so we would actually have to sit there and manually add those up if we wanted to do that. Another way we could do that is by using the field calculator. So I'm going to add a new field called age 0 to 29, and that's going to be a short integer. I'm going to hit OK. And then when I come back here, I have my new field. I can right click on it and go to field calculator, and I want to do age is under 5 plus 5 to 17 plus 18 to 21 plus 22 to 29. Hit OK. And bam, there are your results. So that's a quick way of adding up fields in your attribute table should you need to do it. There's also a lot of other formulas that you can use. Like let's say you have a population number from 1990, one from 2000, and you want to calculate percent change. You can just put the formula in for percent change between those 2 fields and calculate that. So there's lots of fun stuff you can do with the field calculator, especially if you're really strong in math. You're going to love this because it does some really neat stuff. So I'm going to, again, delete that field so I don't mess up my original data. And I'm going to close that. So I'm going to switch now to a different view. Notice right now, and up in your table of contents, that you have all of these different options here. And this is something that, especially when intro students, when first getting started, this can be a very frustrating thing if you don't know what's happening. But as soon as you add a table to your table of contents, you go and it changes to this view, list by source. And that's because under the list by drawing order, tables can't be drawn, so you don't see them. So when you add one, it automatically shows this where you actually see the file path. And when we look at this particular example here, this is the same data as before, just a little bit different. We can see that we have a shapefile of all the Dauphin County block groups, and we have a table that's associated with it. This data for the Dauphin County block groups, I downloaded from the U.S. Census website. It's what's known as Tiger files, and every year the Tiger files are updated because the geography does change over time as population grows. So this is just the most recent. So if I open up the table to see what I have, when you look at the table, this is pretty unimpressive, because all it's really telling you is different ID numbers that's associated with it. Like, it gives you its FIPS code, its the track number, and its block number. And collectively, all three of these things together are what's called the STF ID field. So that's actually the unique indicator for each block that you see. And if you didn't have the STF ID field, from what you just learned with the example of the representative, you could actually create a new field and just add these three values together, and bam, you have your STF ID field. But this is just showing the actual geography of where the census blocks are. Now, from the U.S. Census website, I also downloaded a data table. And if I open up that table, you're going to see that it has the population for 2000 in it. It has the ethnicity breakdown in there. It has male versus female, and the age cohorts, whether they own or rent, and lots of other good fun stuff. So essentially what I want to do is I want to append this table to this geography so that I have access to those attributes. And this hopefully is a review from intro, but I'm mentioning this because I imagine a lot of you could potentially use this technique to get your data for your final project, or even for the Yellowstone thing. So I'm going to right click on here and go to Joins and Relates, Join. And then we have to select what type of join we're going to be using. We're going to join attributes from a table. We pick which field the join is based on. And before I do that, notice that this has the STF ID field. This has the STF ID field. So that's the join field. Now, one thing to mention is the fields don't have to be called the same thing. Like, this one could be called ID number and the other one called STF ID. As long as they have the same data in this part, it doesn't matter what the field name is. So don't let that deter you if you're trying to join something. Like, sometimes even like with joining county, like it might be county name in the shapefile and just county in the spreadsheet. It doesn't matter, just as long as it has the right data in it. So again, I'm going to right click on here and go to Joins and Relates, Join. Pick the field that it's based on, which is the STF ID, if I can actually select it. And I'm going to keep all records and just hit OK. This one's a large one, so you can notice that it's thinking a bit. Now that it has thought a bit, if we open up the attribute table, we're going to notice that those attributes from the table are now appended to the shapefile. If we remember that when you do a join, that join only exists within this particular ArcMap project. If I go to add this data now to another empty ArcMap project, this is not going to have any attributes attached to it. So in order to make a join permanent, what you have to do is right click and go to Data, Export Data, and export it as its own shapefile or a feature class. So just a reminder about that. Also going to show you this because this is the most popular way of creating GIS data, and that's by extracting it from some that already exist. And Alexa, this example's for you for the hack project that you're working on. Let's say that you were asked to create a GIS file for all the counties in the hack service area. The way that we can do this is by selecting those counties in the service area. If we don't know our counties, we can label them so we can look at them. And the counties in the hack service area, and I need to turn on my tools toolbar. are Franklin, Adams, Cumberland, Perry, Juniata, Dauphin, Schuylkill, Lebanon, Lancaster, and York. So essentially what I'm doing here is just holding my shift key down while I am selecting those on the map. Another way you can select them is just to draw a box that touches all the ones that you want to be in your file, and it will select them. Once they're selected on the map, you come over to the source layer and go to Data, Export Data, and export that as its own shapefile. And I'm just going to stick it in a random location. I'll put it in my and I'm going to make that a shapefile and call it hack_SA for hack service area. Hit save. Add it to the map, and voila, I have a new file. So that's probably the quickest and easiest way of creating GIS data, is by selecting from data that already exists. Another type that many of you are going to be getting is data that's in longitude, latitude coordinates. Like you see here, I have a bunch of frontier forts. Not every one of them I have coordinates for, but the ones that I do, we can display on a map. The way that we would display these on the map is by right-clicking on the sheet, go to Display XY Data, select longitude as the X field, latitude as the Y. Make sure you look at this, because this doesn't always select right, because what it's doing here is selecting the coordinate system of the data frame, and that's not appropriate for latitude longitude. Latitude longitude is always WGS 1984. So let me go up and select that. Go to Geographic, World, WGS 1984, and then it pops them on the map. Again, one thing, just like the join, this is not a permanent thing that exists somewhere else. All we are doing here is displaying the data. It's not actual saved data yet. If we want to save these, we would have to go to Data, Export Data, and call them what they are. I'm going to just call this Frontier Forts. And add it to the map. Now I can get rid of this, and I can get rid of the table. So that's working with XY data. Okay, let's see. Is there any other examples I want to show you? Yes. Last one, and this is the fun stuff. So I have here a spreadsheet that has a few bars in Harrisburg on it. And I actually added the wrong one. Let me go and add the right one. Not sure why those are not geocoded. Let me just take a look at that again. Let me quickly just geocode these, and it's a good review for geocoding. So I'm going to geocode these addresses. And to geocode, you have to be logged into your ArcGIS Online for Organizations account, which I am not signed in at this point, so I'm hoping that pops up. Yes, it does. And you log in. And remember, geocoding takes credits, so be careful with what you geocode, because it eats the credits of our hack accounts. So now that we are logged in, you select the appropriate fields, and the address is going to be street, and then zip. I'm just going to keep that where it is and hit OK. And it matched all but one, and I'm not going to worry about that one just yet. And it puts them on the map, and I'm going to zoom to that layer. Now, let's say that I'm actually making a map of this, and I'm going to turn off this. And let's say I have a base map that I'm using instead to show where the bars are in Harrisburg. This is very useful stuff, by the way. Just going to put it on streets for now. And that's probably not the best choice of a base map for what I'm trying to do, because my symbols are going to get lost. As the base map is adding, what we want to do is, and I'm actually going to turn my base map off so it doesn't slow us down. Okay, there we go. So let's say that I want a customized symbol for my bars. We can build our own symbols in ArcGIS, and we can build them by kind of drawing them ourselves within ArcMap, and drawing is a term I use loosely because it's not really drawing, it's just basically building a symbol. Or you can get an image from the internet or wherever of something that you're looking for, and you can save that and upload that image to be your icon. So, and that's kind of what I did for this, is that I just did a Google search on bar images and got beer mug images, got a lot of pictures of beer mugs, and I decided which one that I wanted to download. I tried picking one that had a smaller size to it, because I didn't want something that was large because it would just blow it out. So I did pick something that was a little smaller. So if I want to build a custom symbol, where I start is my Customize menu, and then Style Manager. Under here is all the Esri styles that we have. If we want to build our own, we go into our Users area, and this is going to be a marker symbol. So, and I already actually built it, so I'm going to delete that. In your marker symbol area, just right-click and go to New, Marker Symbol, and then it's going to take you here to your symbol property editor to allow you to create your own symbols. If you're doing something from a picture, you obviously select Picture Marker Symbol, and then you navigate to where your image is. So this is my cute little beer mug. I hit Open. I size it the way that I want. I'm going to make it a little larger. And then I hit OK, and then Close. Now when I come over here to symbolize this, notice that my little marker symbol is now there. I can hit OK and OK, and it's now symbolized by a little beer mug. And this is problematic in a couple of ways. I mean, you can pretend that this looks beautiful, but it's obviously that they are a little bit pixelated. So it takes some work on your end before actually even using the image. One of the things I would have done with these, for instance, notice that there's a white box around each one. That looks just not good. I would have taken it into an image processing thing like Photoshop or GIMP and gotten rid of that white background, so you just have that outline of the beer mug. Or I would have just selected a different one when I was selecting images when I was looking on the internet. So be mindful of that. And this is something, when you look at a map or something and you say, oh, that looks stupid because the person left this box around it, those rules apply to you too. You know, like I won't actually put this map out as something that's cool and useful because of the fact that that box is around there. If you know there's a problem, contend with it and get rid of it. Like that box would be gotten rid of, or just don't use the image. Don't try to force things. And make sure that it's clear and not pixelated, because it just doesn't make for a nice design. So that should be a rule that you always keep in the back of your mind, is make it look professional and polished, and that's the number one priority with symbols and any map, quite honestly. Now, the other thing you can do in terms of building symbols, we can go back to our Customize menu and go to Style Manager and go back to Marker Symbol. You can also build marker symbols from all of these things that you see here. So let's say you can look at the different characters, you can build them from this. Let's say that we want to build an interstate sign. So let's say I want to build one for Interstate 81. So essentially what I can do is click this. I can resize it. I'm going to do everything as so that you can actually see it. I'm going to do it as an 18. You have that. Then you want to add another layer. you add the other part of the shield and size it right. And I think I had that as 18. And then you can move these around. Like I would take this one down so it's below. And then this, I forget what colors this is. I think it's white. Make that white so that you can see that. We can add another layer and add the top part of it, which is this, and make that 18. I think that's red. Sad that I don't know this off the top of my head. And then this area down here, the bottom part, is blue. And make that 18. And blue. So we have the interstate symbol. And I'm going to take this, move that up. I'll actually just turn that off completely. Now let's say I want to add the number 81 on here. So I can switch this back to simple marker. I'm sorry, character picture symbol, and then just select your favorite font and put the numbers in there. So 8. And move that up 1 so it's on top. Make that white. Make it smaller. You can move it left or right. So if I want to move it to the left, I can do that. If I want to move it down up here, you can do that. And then you just go and add another layer. Pick the same font that you had. Arial narrow. And move it appropriately. Hit OK. Name your new symbol. Hit close, and then when you go to your symbol editor, you're now going to have that as an option. And it looks a little bit dorked up there. I would have spent more time cleaning that up. But you can see the general process for creating new symbols is just going to Customize, Style Manager, go to whichever type of symbol that you're creating, right click and go to New, Marker Symbol, and you can use, like there's the symbols in here. You can upload a picture. The one that I use the most is character marker symbol. You have all the Esri fonts in here, so that's actually kind of cool, so you can use those as a starting point. And then you also have the links to every different font that's in the program. So you can have a lot of fun with symbol creation. So I encourage you to utilize that because you can make some really nice customized snaps that way. I'll put a little how-to document up on D2L that shows you how to do that if you need step-by-step procedures for that. So with that, good luck on your 2 assignments. The book assignment on data, there's some little trickiness in there that's intentional, largely because I want you to look at the data closely and kind of try to see if you can figure out what's wrong. And then the Yellowstone assignment, this is where you guys are free to really be creative and try to show your GIS chops and show how you can essentially communicate the message that's being asked. You have 2 weeks for the Yellowstone assignment. I suggest work on it this week very hard because next week I'm going to be giving a pretty substantial assignment. So the more you can get done this week, the better off that you will be. If you have any questions, email me, post on the discussion board, ask your fellow students. But yeah, get in touch if you need help with anything. Good luck.